There we go. Okay, thank you very much all for coming. The title of my presentation is Using R to Explore the Treatment of the Coronavirus Pandemic in the Media System in January through July 2020. So last year, the first half of last year. I'm going to be talking about this from a set of substantive questions that I and my colleagues have about how the media system works. And we use the word media system rather than news media because we want to really get it, capture the outlets that are contributing to the public discourse, even if they aren't what we would consider news. And I'd like to first recognize my collaborators, Rebecca Auger, Alex Rochefort, and Brianna Trufiro, who are PhD students in the Division of Emerging Media Studies working with me on this project, and they're on the call. So hello, thank you for coming. And they've done a good deal of the work and the data analysis that I'm going to be showing today. So let me begin with those substantive questions that we're interested in answering, because they do guide the techniques that we are using and also innovating, because a good part of what we're doing in this project is feeling our way with some tools to answer these theoretical questions. So in this project, we're honing in on questions that look like this. So what aspects of the COVID crisis did media prioritize? Which ones did they give a lot of attention to? How did the story of COVID change over time? So how did the stories that the news media were telling and the themes that they were using evolve over the course of, in our case, the first 6 months? And then, certainly as important, how did partisan media differ in how they depicted COVID and in terms of the stories that they told about COVID? So I'm not going to spend enough time talking about our theoretical research interests, because I do want to focus on the data that we're gathering, but I think it's important for you to understand what we're interested in as well. Even more specifically, one set of questions we're kind of curious about is, does the media system constitute what we might call a hydraulic system, or does it have an elastic supply? Here's another way of putting that. In the media system, does attention to one object or topic necessarily push out other topics? This would be kind of the hydraulic idea. Or is it possible that the media system responds to kind of the amount of news that's out there and adjust accordingly? Is media attention a zero-sum game? So let me give you a quick answer to that we developed. Most of the data that I'm going to be showing you today comes from a platform called Media Cloud. Media Cloud is an open source database of news articles developed by folks over at Harvard mostly. And anyone can access it, mediacloud.org. And it collects articles from, I think now, tens of thousands of news outlets, and it collects them via their RSS feeds. So its data is a little bit subject to the quality of the RSS coming out of a given news outlet, but it's a really useful tool with a few limitations that we'll talk about. But it's data from Media Cloud that we are using. So we used Media Cloud, and we used their API to draw out stories about the coronavirus from January 1st through June 30th of last year. And to begin answering this hydraulic question, Rebecca, one of my collaborators, created a couple of charts. And so this is a very first basic plot in ggplot that I'll tell you about. So straight out of ggplot, this is the proportion of all news articles stored in Media Cloud that were about the coronavirus. And it's just a simple proportion of all the news articles that met our query criteria of including one of a handful of keywords having to do with the coronavirus and COVID and pandemic and stuff like that, out of all articles that were published by the outlets in Media Cloud. And so it clearly rises from nothing in early January, so no coverage of the pandemic, to a bit of coverage. This is the early period when the pandemic was circulating internationally, of course, first in China and then in Italy, most notoriously. And then this is a year ago, this is last March, when by the end of March, COVID stories were occupying above 80% of all stories covered in the news outlets, which is pretty amazing. And since then, it has tapered a little bit, but by the end of our study period, it was still hovering around half of all news articles. So this is obviously very descriptive, but I think important beginning plot in understanding the data that we're working with. I'm going to offer you another one, and I apologize to anyone with color blindness issues. One of my best statistics colleagues is colorblind, and so this wouldn't work for him, but this is how we did it. So this shows total counts. So it's no longer proportions, but to take a look at that hydraulic question, this is total stories, volume of stories about COVID. That's in the green blue here. And you can see the same general pattern that you just saw a moment ago. And then the red is all stories. So this is COVID stories plus all other stories. And so what's interesting is you can see kind of a combination of what I described as the hydraulic function, as well as the elasticity of supply, which is that we generally have a constant level of overall stories. The size of what the media produces is about the same from one time to another. And the end of the series is about the same as the beginning of the series, but it also did seem to respond. It's quite clear that COVID took up the bulk of the media space at that point in late March. But clearly the total news output also increased by a substantial amount, by almost 50% at one point here. So the news organizations were becoming more active in terms of producing more overall news content during this time. So we also see sort of elasticity in the supply of news media, which begins to answer that first question of ours. Okay, let me go into a little bit more detail about the study that we undertook. What we looked at were major news media outlets that we could categorize into partisan, in terms of their partisanship. And this is the final framework that we used. We aimed for 4 news outlets from each of 5 categories, from left-wing media to right-wing media, with centrist and center-left and center-right media in the middle. We aimed for 4 of each. In reality, this category of center-right media is quite sparse. And so we wound up allowing ourselves to have 5 in the right-wing category and 3 in the center-right category, but it's basically, it's, what is that, a 20 overall. These outlets are categorized by their audience, not by any measure of their coverage. And we're drawing on Yochai Benkler and colleagues' book here. And then I just mentioned the reason that we have slightly fewer center-right categories. But basically, if you look at the social media behavior of people who share links from these outlets, these are shared mostly by people who identify on the left. So we're looking at these news media and their coverage of the pandemic because of their clear partisanship. And also we're sampling from the top of the distribution. These are some of the biggest, most read news outlets in the United States. So when I talk about these categories, left, centrist, and so on, it's specifically in our data, these outlets whose articles we are measuring. So we used a technique called correlated topic modeling, or CTM, to characterize the discourses taking place by these news outlets. So we collected all of the, I think it was tens or hundreds of thousands of articles from all of these outlets that were about the COVID pandemic during those 6 months. And we ran now a series of correlated topic models on them. I'll be very brief because this talk isn't about correlated topic modeling, but this is derived from Bly and Lafferty from 2007. It's based on LDA topic modeling with some revisions. It makes some improvements. In our specification, we gave the CTM 2 features that allowed it to, two sort of meta features to allow it to create its topics. One was we told it the partisanship of the media producing each document, and we also told it the date on which each document was produced. And the intention here was to allow the CTM to find some of the distinctive patterns within particular clusters of either in terms of time or in terms of the partisanship of outlets. Again, I'm not going to go into a lot of detail here, but we can answer questions about this later on. When you run a topic model like this, the machine will cluster together documents, and it will give you some information about the meaning of the topics. And often you get a result like this. You have these word weightings. And so for each topic, in this case, our overall topic model produced 75 topics out of 200,000 some documents and a 35,000 word dictionary. For each topic, you get these word weightings that are guides to interpretation of the topic. So you get this thing called highest probability, which is just basically the words with the greatest probability of occurring within that topic. And then the other scores are essentially variations of probability weighted by exclusivity. That is, how much a topic belongs in one, how much a word belongs in one topic as opposed to all of the topics, and so on. Anyway, the point here is you can quite clearly see clearly identifiable topics in each of these topics, even just from this very rough set of word weightings. So this is obviously about the Senate and Congress and political responses to COVID. This is about the death tolls, statistics coming out of Johns Hopkins, and so on. And this is about the economy and the stock market. I'm going to point you to a couple of other topics that we pulled out that I'm going to be talking about more in a moment. These are topics, again, with the arbitrary numbers 29, 30, and 31. Here's a topic that's about hand sanitizer, about cleaning up, about protecting yourself from COVID. Here is a topic 30, I'll be talking about in just a minute, about these sort of drugs that were proposed as treatments. Azithromycin, hydroxychloroquine, and so on. You see FDA in there because the FDA was involved in either approving these or not. You see malaria because hydroxychloroquine was developed as a malaria drug, and so on. So this is what the sort of our beginning stage of looking at these topics was. And we go a little bit farther. The STM package has some tools for exploring your topic model. One of them is this nice function, find thoughts, which allows you to pull out documents that score very high on a particular topic. So it's important to go beyond sort of the word weightings to get a sense of what your topics really mean in terms of which actual articles are scoring high on topics. And find thoughts is a function for doing that. So if you've ever worked with topic modeling, it's a very iterative process of running multiple topic models, looking at the data, reconsidering what you're seeing, and so on. And we're in the midst of that right now. So what I'm showing you is a bit of a work in progress, but I think it's an interesting process that we're developing to explore this data. This is what the data looks like. So this is the structure of the data. I'll just highlight a couple of things. We basically have the date of the story. We have the title, which is the headline of the story. We're not actually modeling on the basis of the title. We're modeling on the basis of the basically bag of words that Media Clouds gives us for each article. It doesn't give us the full text of the article, but it gives us word counts essentially for all words that aren't stop words. So I noticed that someone was interested in text processing. We didn't have to do a huge amount of that because Media Cloud has done most of it for us, but I'm happy to talk about that if people want, if there are questions. And then for every news story, we have the name of the medium that produced it, the partisanship, the category that we have assigned it, and then a score on every one of the 75 topics. So here I've given you the first 14, but every article has this decimal score, which in structural topic modeling is referred to the topic prevalence. It's the estimate of the prevalence of that topic within a document. And you can see most of the topics have very, very, very low estimated prevalence because there's probably just a couple topics that scored quite highly for any given article. That'll be sort of notable in a moment. Okay, so let's get down to the actual data. So we can look at the topics over time. I've given you the specific code, sort of the dplyr code in the right, but you don't need to read that. It might be useful to folks watching the presentation later. What we've essentially done here is we've averaged across our entire data set, we've averaged the score for one particular topic. This is topic 71. We've taken the average score of topic 71 over the span of our whole time, and then we've let ggplot smooth it out with a default smoothing function. And you can see this particular topic rose very rapidly out of January, was highly prevalent in February, March, and April, and then died down a little bit after that. This topic is actually a topic that is about the origins of the coronavirus. So there's a lot of discussions in this topic of China and Wuhan as the origins of the coronavirus. So this is why you have the high spike in February, basically. It's notable, though, that this topic sees a resurgence in April, and we will talk about that in a moment as well. So this graph is a particular kind of graph where we have taken, I'm not going to go into that detail for a moment. This is a different look at the very same data. So whereas here we were looking at the raw number of articles about this topic, here we are looking at the percentage of all articles that went to this topic. So I think this highlights the importance of looking at your data in a couple of different ways, because this tells a very different story. This looks like something that was a big deal and then just doesn't exist anymore. We can see from the raw numbers that that isn't the case. There's more patterns to that and so on. But the reason is this is as a percentage. Because our denominator is made up all of articles about the coronavirus pandemic, the total articles about the coronavirus pandemic are increasing substantially throughout this period. And so the diminishing proportion is reflective of actually a somewhat constant rate of coverage, but a diminishing proportion as related to all the other coronavirus coverage that's happening in this space. So that's an important note that I'll make and that we've discovered here. Now I want to zoom in on one particular episode as kind of a case study. This was the episode of Donald Trump allegedly encouraging folks to drink bleach or disinfectant or to inject disinfectant. These were comments he made on April 24th last year. We were interested in this episode for a couple of reasons. We wanted to know, how did this specific event fit within the general media landscape? We had the sense that it was kind of a big deal, that it seemed as though all of the media had suddenly latched onto this story for about a week and kind of wouldn't put it down. And this was the big story. And we wanted to know, had it displaced other parts of the COVID crisis, maybe more important stories, for example, about how we're going to deal with the economic effects or how people can cover themselves, protect themselves, or what have you. We also wanted to know, was it treated differently by different parts of the media system? So we used the topic modeling that we had developed to cut into this question. First, we had to figure out which topic had really, which topic had identified itself with this story. And it took a little bit of work, but we settled on topic 30. And this is a plot of the average scores of all articles on topic 30 over time. And I'll note a couple things. One is that there's this clear spike right here, which is indeed April 24th, and then the following days here. So topic 30 does seem to be strongly associated with that story. However, even at its peak, notice that topic 30 only makes up about 4 or 5% of all stories about the COVID pandemic, even on April 24th. So that's not a huge proportion. This is a slightly different way of looking at the data that I'm going to skip over in the interest of time. By using some simple dplyr tools and subsetting in R, you can do fairly quick zooming in and zooming out to get closer looks at the data. So in this case, we're looking at the same thing, but now we're zooming in, we're filtering just down to this 9 or 10 day period between April 20th and April 30th to zoom in on that peak, on that spike that we had previously identified before. So this is some of the usefulness of R and dplyr, as what we've actually found is actually quite an effective and efficient and time useful way of zooming in and exploring data. So we're doing a lot of just going in and out, selecting different portions of the data and looking at it as we explore at this stage. One thing we do is we break apart our data in terms of partisanship. So this again is still topic 30. It's that topic about hydroxychloroquine and about Trump's disinfectant comments. And now we have split up our data by the party of the news outlets. So you've got, and I again apologize for color issues, so I'll describe it a little bit. Essentially, we have left media spiking to a huge extent on April 24th, and again, a little less than a month later. The other news media also show some response at that point, but it's not nearly as large as the left media. Here's the same plot smoothed out, so you can see that much more clearly. And you see down here is all of the other media, all the media that aren't left media, and they aren't responding very strongly to those events. So the response to those events, to Trump mentioning his the bleach comments, and then this latter event, which is when he said he was taking hydroxychloroquine prophylactically. These were really events that were seized on by left media, but much less by other news media. However, contrary to our assumptions, neither of these stories ever played a dominating role in the overall media system. So they spiked out for the left media because they're smooth, you can't quite see it. But on the peak days, they were a little over 10% of all media coverage from the left media about COVID. So a little over 10% of all COVID coverage by those media was about this topic. But that's still not very much, and it really doesn't square with our intuition that this had been a dominating story in the news media system, which I think humbled us a little bit in terms of how we thought about news media coverage in this context. A little more about the kind of data exploration that we're doing. So we are spending a lot of time going back and forth between these graphs and looking at the actual data. So in this case, again, it's a simple subsetting command in R to look at a particular date. This is April 24th of last year. We're looking at all the articles whose highest topic was topic 30. We're looking only at news media from the left, and then we're looking at their media name, which I've cut out, and the headline of the article, just to see, are we indeed looking at what we think we're looking at? And in this case, yes, it's quite clear that Trump is talking about disinfectant. And there's also another story that actually happened the same day, which was about the FDA issuing a warning about hydroxychloroquine. So that's an important side note that we need to make as well. I'll take a quick look at this chat. 5-minute warning. Cool, thanks. Okay. Here's a little more of that. This is the latter day rather than the May date with the same topic. So this is about Trump saying that he's taking the hydroxychloroquine. We also did some kind of quality checks. So we were a little bit concerned that there might be stories about Trump's statement, so about this specific episode that we're interested in, about his disinfectant statements that weren't captured in our topic model in topic 30. And so this is, again, another subset where we're looking at the same stuff, except now we're looking at all the articles whose highest topic wasn't topic 30. And indeed, we don't find many cases. So topic 30 did a reasonably good job of identifying or incorporating articles from this episode. But we did find a few that belong to other topics. So we're in the process of refining our approach to identifying specific episodes for certain kinds of analysis. Let me offer you a contrasting case. This is a different topic. This is topic 71, which I told you about before. And I showed you previously that overall coverage of topic 71 had spiked in the early weeks and months of the pandemic as people were figuring out where this virus was from and what it was about, and then it had died off. Well, then there was that little further increase in April, which we were interested in. So here we filtered into our data after March 1st, And we again are looking by news media. And I'll describe it again in case anybody can't see the colors too smoothly. Now we see that beginning in March, right-wing media picks up on and greatly increases their attention to that topic, to the Wuhan, China topic, which is kind of interesting. While again, all of the other media are doing other things. They have kind of this low baseline level of attention to that topic. So in April and May, there's a lot of right-wing media attention to where's this virus from and so on and so on. And we can cut into that a little bit, again, using a simple subset, looking at one of these days, the middle of April. And you can see that it is, it's articles reminding people about where the virus came from, and also some essentially conspiracy theorizing about the origins of the virus. So here you have a video about the Department of Defense looking into claims that the virus originated from a lab in Wuhan, and so on. So right-wing media is taking this very particular narrative and choosing, even though it's well established where the virus is from, choosing to devote increased attention to it in April of 2020 for reasons that are probably interesting, although we haven't fully sussed them out yet.
Ding.
Okay,
Ding.
perfect. That's 1 minute, right?
You have time.
Okay, well, it's the last slide. So let me just say what we're working on right now. One is, the work that we've done illustrates a difference between topics and stories. So our topic model is very good at, surprisingly good at, given my other work with topic modeling, surprisingly good at identifying these larger themes of the coverage. Our topics are almost all very, very coherent. We see very clearly what people are talking about in them. On the other hand, they don't always align exactly to what we think of as news stories. When we think about them, we really think about these specific episodes of, Trump said the stuff about disinfectant, and then how did that play out in the media system? Our topics didn't always perfectly align with those, so we're working on how to mesh them, and we're working on thinking through conceptually which of them are more important if we want to understand the ways in which news media covered coronavirus. We also are integrating the data that I've just shown you with data from other sources. We're using Facebook data via their own platform, CrowdTangle, which is an interesting way to see how much, for example, different stories circulated on Facebook. Twitter is another source that we haven't actually used much for this project yet, but is a available one. Television news, obviously all of the news out there is not online news, and although Media Cloud does a really nice job of capturing a variety of forms of media, we've found that it doesn't do a great job with cable news. So it does have, for example, from Fox News, it does have daytime news programming from Fox, but it does not have Fox's evening hosts, which are the real conservative hosts that you think of when you think of Fox, Tucker Carlson and so on. So we're supplementing that with the GDELT archive. We need to look at events data, when specific things happened in the real world and how that was reflected in the news media. And then we also are looking at Google Trends as a comparison point to what were the news media saying and what were people thinking about and searching Google for. So I'll leave it there to leave time for questions. Thanks for your attention. And just one more shout out to Rebecca, Alex, and Brianna, who've been my collaborators and put together a lot of the data that I've been presenting. Thank you.
Thank you, Professor Wells. And now if anyone has questions, you could unmute, or you could use the raise hand function, or you could type your question in the chat. Okay, Professor Wells, actually I have a few questions. I think your work is very interesting. And I'm wondering, so at the beginning, you classify like the news media organizations to be like left, center, right? I'm wondering, how did you do that? Or is it more like a conventional thing?
We borrowed from the classifications from the team that created Media Cloud, Yochai Benkler, Robert Ferris, those guys, Hal Roberts, and they gave each of the news media a score, which was based on a small network analysis they did. So in 2016, they categorized Twitter users according to their uses of basically liberal or conservative hashtags. And then they looked at which users had shared which news outlets' articles. I think I have that right. And so they had a sense of the makeup of the audiences of the news outlets based on the sharing behavior of those Twitter users. There's clearly limitations to that. Like it's here, you're classifying the news media based on their audience. You're not classifying them based on their coverage. That would be a different measure, which probably would align, but it's not what this one is based on. So it's a little bit of a rough and ready measure, but it is empirically grounded.
Thank you for answering the question. And looks like we have a question from a guest. So they are wondering, sorry, how did you gather all this data? Did R collect for you, or did you have to manually collect it?
We didn't have to manually collect it. We collected it from Media Cloud, and we were able to use Media Cloud's Python API to collect the data. And once we did that, it wasn't extraordinarily difficult. We were able to specify our queries and extract the data from Media Cloud. Media Cloud is set up to provide data for research projects. So it's a really nice source for that. I did mention there's some limitations to it. It doesn't have certain kinds of coverage. You need to look out for those. It also, some news outlets don't have good RSS feeds going into Media Cloud. So Media Cloud will tell you that in terms of the health of a given news outlet, but you need to be aware of that as well so that you know what you aren't getting in your data. Can these software packages, yeah, I'm reading from Zara. Thanks, Zara. Can they be used on non-English data sources? Would I have to translate them? I don't have experience using them on non-English data sources. They certainly are being used in different contexts. And maybe others would know more about this. My sense is that you would need a package maybe that has adapted the tool to the particular language. I'm trying to think if you could process the data, how well. On the other hand, I think that if you could process the data appropriately, something like STM would work pretty well, because STM is based on groups of words. It's a bag of words method. So as long as the words are discrete, and as long as they semantically cluster together into topics, you should be okay. I'm trying to think if some kinds of languages, I think most languages that would work. So that's my first kind of vague answer. Okay, yeah, I see Jay Wook. I'll just read these, see if that's okay. Okay, Jay Wook. Jay Wook asked about how many topics. So this is a very good question, and one that we are working with right now. There are algorithms, kind of out-of-the-box algorithms, that will tell you what number of topics your documents should have. And so we used one that that basically, it's an algorithm that's basically based on maximizing semantic coherence and exclusivity. So it wants to maximize how well each topic is coherent with itself, and it wants to maximally differentiate topics from one another. And there are metrics for that your model can maximize. So that's sort of like the out-of-the-box algorithmic answer to that question. And that's where R75 came from. But the sort of in the field, topic modeling is increasingly encouraging researchers to specify a couple of different parameters for their topic models. And so try maybe 3 or 4 different numbers of topics and look at the outputs and make decisions from there about how many are most appropriate to your purposes. The ideas of coherence and exclusivity are still important. You want your topics to obviously differentiate from one another and to be internally coherent. But beyond that, there may be you might have different purposes for different approaches. For example, in some studies, you might want very general topics like all the topics about COVID that have something to do with the economy. You might want all those together, or versus all of those that have to do with protection, disinfection, vaccines. Maybe you want all those together. On the other hand, in other study, you might want very granular topics. You might want topics that are more at the level of an individual news story. And so you might want even more than 75 topics to try to get the model to produce those. So it is a very iterative process, and it isn't, at this point, the use of topic models isn't, I don't want to say it isn't precise, but it isn't explicitly defined. It is important for the researcher to make educated decisions at a number of stages in the process.
So Professor Wells, I actually have another question. I'm wondering more about the text. Oh, you can answer Chaz's question first.
Hey, Chaz. Yeah, stop words are a common issue that needs to be dealt with in text processing. So stop words are all of the parts of speech that don't have a lot of semantic meaning, that aren't going to help you understand a topic. So they're like and, of, the, to, all those kinds of things. It's a standard step in text processing to remove stop words, to just drop them. Unless you're doing a more sophisticated syntactic analysis like parts of speech coding, where it's helpful to have sometimes those words. But in something like this, where it's a bag of words approach, where you really are kind of taking all of the meaningful words and shaking them together in a bag for each document, you don't want the stop words in there. So you take them out. In a text processing package like STM, there are very easy ways to do that. Like it's a line of code, and it automatically has a list of stop words in English that it will remove for you. We didn't even have to do that because Media Cloud, again, we weren't working with full text of these articles. We were already working with word counts from each article from Media Cloud, and they had already processed it, including removing stop words. So that was a step that we didn't have to take because it had already been taken for us. Yeah, good question, Chaz. You absolutely can do that. Yep, you can ask your model not to consider. You first of all could just cut out the words altogether, remove every occurrence of a given word, or you could tell the machine that you don't want it to model on the basis of a particular word. Structural topic modeling has a few different options for doing that. And not in this application, but in other contexts, I have found it useful to do that. Okay, yeah, what do I teach? I teach political communication in the College of Communication, both in the Department of Journalism and the Division of Emerging Media Studies. So I teach a seminar on political communication and new media, and a couple of other seminars. And right now I'm teaching a class on using R to process data, text data, and other forms of usually social science related data. C, did you have another question?
Yeah, hi, Professor Wells. I'm wondering more about the text processing process because I was interested in taking class in natural language processing. Is that kind of how it works?
Is natural language processing how it works?
Is natural language processing kind of like what's happening with the text processing, or was it like some other techniques?
Yeah, so I have to say I'm not very experienced with natural language processing as a whole. Um, uh, so text processing would be part of natural language processing. I would say natural language processing is the field of using machine tools to process language, natural language. So topic modeling would be one natural language processing approach because it allows us to derive meaning from natural language. And so the text processing that you do to do topic modeling would be part of natural language processing. But if you can get a good natural language processing class, um, um, the stuff that I've shown you it would very quickly be quite basic for you, I think, and you would be doing more advanced things. And the world of natural language processing is vast and it's growing so quickly. It's just super fascinating, from topic modeling to sentiment analyses to parts of speech tagging. So it's a very exciting space to work.
Thank you. And looks like the guest has another question. Do you have a webinar we can attend where you teach processing of data using R?
Yeah, I don't myself.
Oh, Professor, you're muted.
Thanks. I don't myself, but I think I can point you to a couple. Folks have done workshops, which are sometimes really useful. Just give me a second here. I'm looking at one of my previous students. I'm not finding it at the moment. So there are a lot of there's a lot of materials on the web for learning these kinds of skills. So you can go all the way from something like Coursera or what is it called? Code Bootcamp, Code Camp, something like this. And so I use some of those at one point or another. And they're a good place to start to just get your hands on the data and get some experience. There are also classes on campus.
Professor Wells, I have one last question, if no one else has any question. I'm wondering, because in the beginning of your presentation, you talked about how those coverage is a proportion of the total amount of coverage. But how can you like collect all the, how did you decide what is the boundary of like the total amount of coverage?
Yeah, it's a very good question. And here, my research assistant, Rebecca, who wrote this Python script and interface with Media Cloud, could chime in. But Media Cloud will tell you how many articles they have from each news outlet on each day. So you don't actually have to collect it all and count it. But it's the total quantity of all the articles that Media Cloud collected from each outlet. And so they've got these open feeds from RSS where they're collecting this fire hose of data from the outlets. And so the proportion is, of all of the articles they received on a given day, how much of it fit our criteria of being about COVID. Of course, that could be subject to some kind of systematic error, but I don't know why we would systematically be missing why would we would systematically be missing non-COVID stories over COVID stories, for example. So I'm reasonably confident in the overall proportions.
Thank you.
Thanks.
Let's wait for a few seconds and see if anyone else wants to ask a question. If not, I think this has been a really successful event. Thank you so much, Professor Wells, for giving this talk. And thank you to the Hariri Institute for supporting the logistics of this event. And thank you for making this event happen. And so our next Did You Know You Could series will be on about how to use social media to amplify your research, and it will be hosted by our Gina Mantica. And yeah, I think that's it. Thank you everyone for attending. Thank you, Professor.